Okay, let's start our notes today with we are doing proportional and non-proportional situations. Our essential question is, how can you distinguish between proportional and non-proportional situations? What we are doing today is bringing together what we have been working on in class for the last several days, and actually a couple of weeks. If we have a non-linear situation, in other words, the graph is not going to form a line, well, that kind of falls into being Okay. We haven't seen a whole lot of those, but they will be non-proportional. And if you notice here, we're building a table for you. And we've actually looked at two linear situations. We have a linear situation that is of the form y equals kx. This is when the graph contains and goes through the origin. Then it is proportional. So, a couple of things that we might want to make note of here is that m is really k, right there. And if we compare it to our next situation, then you're going to need to think about b equaling 0, because that's the only way that you're going to have a y-intercept of 0, 0. There's your b right there. So b has to equal 0 for this situation. That makes it proportional. So now let's talk about our other linear situation. This is the one where y equals mx plus b. This is b being something other than 0. Your graph does not the origin. Then it is non-proportional. And these are some of the things that we're going to be looking at today, deciding if it's not linear or if it is linear. And if it is linear, then which form of the equation are we using? What's our b? Is it 0 or is it something other than 0? If it's 0, it's proportional. If it's not 0, it's not proportional. Okay, example 1. And I want you to look at the book, and I'm going to show it to you. This graph shows the sales tax charged based on the amount spent at a video game store in a particular city. Does the graph show a linear relationship? Does it form a line? And I would say that yes, it forms a line. Is that relationship proportional or non-proportional? All I have to do is look right here where the x and y axis intersect. That's 0, 0. And to me, that's going through 0, 0. So here's your explanation in the book. The graph shows a linear proportional relationship because it is a line that contains the origin. Now this is in the book. Let's put something in our notes here. So we're going to start with example 1. And I will note that we are looking at page 107. And it's linear because it forms a straight line. and the graph goes through 0, 0. So it is proportional. If you write this down, then you've got a few extra notes besides what's in the book to help you remember why we said it's linear and it's proportional. We're going to do another example. And again, I'm going to show you something from the book. It's on page 108. And it states, the number of years since Keith graduated from middle school can be represented by the equation y equals y is the number of years and a is his age. Is the relationship between the number of years since Keith graduated and his age proportional or non-proportional? So let's look at this. The equation is y equals a minus 14. What I'm going to look at is this part right here. I have a b that is not 0. And if my b is not 0, then I know it's not proportional. It's non-proportional. And I don't need to look at anything else, because if I have a b that's not 0, I know it's not proportional. Let's do another one. This one comes from page 109. And again, I'm going to show you something out of the book. The values in the table represent the numbers of US dollars 3 tourists traded for Mexican pesos. The relationship is linear. It tells us it's linear. What we have to answer is the relationship proportional or non-proportional? And it gives us this table. What it then does is it sets up the ratio of the pesos to the dollars. Remember that our K, our constant of proportionality, is y over x. So when we do y over x, it reduces to 13, and the book shows us all three of them do. So it has to be a proportional relationship, because this is going to work out to where if you've got $0, you get how many pesos? 0 pesos. Let's put some notes in our journal so that we remember what we talked about. And I'm going to very simply make a quick table from the book. And I'll remind you that if it's proportional, then K has to equal y over x. So if we do 1690 over 130 and use a calculator, it reduces to 13. Same thing happens with 3315 over 255. It also equals 13. And 6565 over 505. That will also equal 13. So the ratio is constant. Therefore, it will be proportional. Now we're going to do something a little bit different. We're going to do some comparison. We're going to do example 4. And this comes from page 110 in the book. A laser tag league has the choice of 2 arenas for a tournament. In both cases, X is the number of hours, Y is the total charge. These situations. For arena A, all we get is the equation. For arena B, we get a graph. So we have to look at this graph. For 0 hours, we haven't even started playing yet, we have to pay $50. So there must be a charge for just using the facilities of $50. We'll be charged X amount of money for however many hours. I'm going to come over here to 1 hour, and I'm going to go up, and that's the point which comes over here to 250. Okay, so we're being charged, it looks like, $200 for 1 hour. So that means that then I shouldn't be paying $450, which looks to be true. So we have some situations here. Arena A, at Y equals 225X, we have no initial fee because there's nothing being added, and the hourly fee is $225. Okay. This one is proportional because it will go through 0, 0. Then arena B, that was our graph. What we found is we had an initial fee of $50. Our hourly fee was $200. This one's non-proportional because it went through 0, 50. Okay. So the comparison is this has a lower fee where this one is higher. This charges an initial fee where this one does not. So it's your choice kind of which one you want to go. At some point, one of them will be less. You have to figure out how many hours are you going to be there versus what you're going to do. We will see you in class.